Let's start by reviewing how to make carboxylic acids in the first place. We've studied a number of reactions that will produce carboxylic acids. For example, if we take an alkyne, and treat it with ozone and water, you will get 2 carboxylic acids out. Whatever your R groups happen to be, you'll get 2 carboxylic acids out through the oxidative cleavage of that bond. So that's one way to make carboxylic acids. Another is to take an aldehyde and oxidize it. Generally speaking, you can use harsher oxidants. You can do a Baeyer-Villiger, so you can use a peroxide. You can use nitric acid. You can use dichromate. For example, all of these strong oxidizing agents will oxidize your aldehyde to your carboxylic acid. And of course, we know that therefore we can take a primary alcohol, oxidize it to the aldehyde, or we can oxidize it to the carboxylic acid, right? Like, it depends what oxidant we choose. If we choose a mild one, we go to the aldehyde. If we choose a more aggressive one, we go to the carboxylic acid, right? Sometimes we can isolate that aldehyde, sometimes we can't. Like if we use DMP, yes, we can get the aldehyde. If we use chromic acid, we cannot. We go straight to the carboxylic acid. So here, generally speaking, we're talking about dichromates. We're looking at nitric acid. We're looking at peroxy acids. We're looking at other oxidants like chromic acid. All of these things, any of them will oxidize an alcohol or aldehyde to a carboxylic acid. Has to be a primary alcohol, though. And of course, our other way of synthesizing these comes from the aromatics. Some sort of alkane on your benzene. If you treat it with one of those strong oxidizing agents, that's another one here, by the way, permanganate, you will get the carboxylic acid out. So, a couple of ways: alkynes, alcohols, and aromatic alkanes. We can go ahead and get carboxylic acids off of those. So, lots of options. So with this, we'll go ahead and start taking a look at some of the general mechanisms for carboxylic acid reactions. We'll see that generally speaking, most of them will follow a nucleophilic substitution type pathway, similar to what we did for aldehydes, but a little bit different. And so we'll take a look at those general mechanisms in our next video.